why is that? Well, here's your condition, your third condition in the pumping lemma. So the length of xy has got to be less or equal to p. P is the pumping length from your pumping lemma. Now, given that, y must consist only of zeros. Obvious, right? It's perfectly obvious. Now at this point I'll digress a little, because I find it interesting. When I first came across that, see, I don't know if you maybe you've had this thought yourself, I don't know, but trying to follow proofs of genii, like when I read people like Ed Witten, and others, like you'll get like senior profs of top universities, and they'll write a textbook and you study it, and you just get the impression, my God, this guy truly is a genius. I'm reading the works of a vastly superior mind, and I get that impression quite often. So sometimes I wonder, what would life be like if you were that smart? I mean, how different would it be compared to somebody who's just of ordinary intelligence, as professors go? And even that's it's all relative, right? Now I have a good friend. No, he's not over the 200 IQ range. I mean, he's not a super genius in that sense, but he's damn smart. I mean, he's genius level by most psychologists' standards, I suppose, because his IQ is 180. So I'll never know, but I just wonder what would it be like being that smart, because when I study all these theorems, it's like doing a continuous IQ test, right? You constantly say, now where'd that come from, or why is that, or so. Like when I came across this, given this, therefore y must consist only of zeros. That did not seem obvious to me at first. So I've left it as homework for you to give a kind of brain teaser, if you like. Now maybe you're so smart that it is obvious to you, and I suspect that Sipser, he's no fool. Maybe he is one of these very bright people, and perhaps for him this conclusion that the y here, given this constraint, that the y here must consist only of zeros, maybe that is obvious to him, and it's sort of difficult, and then maybe difficult for him to imagine what it's like for his class when he's teaching, that virtually everyone else, and probably all his students in his class, are not as bright as he is. Maybe they're 10, 20, 30, 40 IQ points dumber than he is, right? So, I thought that was an interesting thought. Some of these, Sipser has a habit of just throwing things out. And I guess maybe for him these things are obvious. I don't know, but from time to time I stumble across some of the things he just throws out. Now here's one of them. Now maybe I'm being thick, British slang for stupid, but I wonder. So so for homework I ask you, given this constraint, show that y has to be all zeros. So do that for homework. All right. Now, if that's the case, if y is all zeros, then if you pump your string x, y, z, your s, just a little bit, so you just have now 2 copies of y, then given before you pumped x, y, z belong to c, therefore x, y, z as a string has an equal number of zeros as it has ones. Okay. Well, now you've pumped it a little, and now you've got an extra copy of y in it. But if this is true, y consists only of zeros. Therefore, and this is pretty obvious, therefore x, y, y, z must have more zeros in it because of the extra zeros you put in due to this y. Okay? So therefore this pump string cannot belong to big C. Because remember, big C, what is big C? well, all its strings have an equal number of zeros and ones. Well, that doesn't have an equal number of zeros and ones. Therefore, this string, this pump string, cannot belong to big C. Okay? I'll ask you to, well, well, I just done it, so you don't need to do that for homework. So that implies that S cannot be pumped. Okay? So in other words, you've found a string S whose length is larger than the pumping length, P. Okay? And according to the pumping lemma, that string can be pumped. So that you know, for all I, where is it? Here, this still belongs to the language, big C, but it doesn't. It doesn't. Okay. So you've got yourself a contradiction, and therefore by modus tollens, therefore proof by contradiction, and therefore your original assumption is false. Okay. So therefore C is non-regular. Okay. So we've proved that with a question mark about this. All right. Okay. Now selecting the string S here required a bit more care than the previous example, as in the previous example 1.73. For example, say we'd chosen a slightly different string. Instead of it being 0 to the P, 1 to the P, say we'd chosen 0, 1, all to the P, right? A different candidate string. So we're trying to find a counterexample. We're trying to find a string S whose size is larger than, or equal or more than the pumping length, little p, and then show that that string cannot be pumped. In other words, x, y to the I, z is not a member of your language. Right? So we're looking for a string S that cannot be pumped, right? So even if you take condition 3, this into account, so even using that, you still may get a string that can be pumped. So if you're trying to find a proof that your language is not regular, getting a string S, a candidate that you show can be pumped, well, that's a sort of waste of time, right? Because you're looking for a string that cannot be pumped. That's the whole point, right? So, well, say you did try S equals 0, 1, all to the power P. Well, that can be pumped, even with this taken into account. Why? Well, let X be the empty string, let Y be 0, 1, and let Z be 0, 1, all to the power P minus 1. So Y, that's the nothing, so, but YZ would then be 0, 1 to the P. Follow that? If you concatenate Y and Z, you'll get 0, 1 to the, all to the power P, because you've got a plus, 0, 1 to the power 1, and here 0, 1 to the power P minus 1, so the two exponents, add them, you just get P, right? And obviously that string has an equal number of zeros and ones. As you pump it, as Y goes up, 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 well, the 0, 1, each time you do it, you still have the same number of zeros and ones, okay? So that pump string, no matter what I is, still belongs to the language, okay? For all I greater or equal to 0, for all non-negative integer I, okay? Right. So your first attempt, let's say that was your first attempt, failed. Failed in the sense that it was pumpable, and that's not what you want. You're trying to find a string that is not pumpable, so that you can find a counterexample and therefore refute the idea that C is regular, because you're trying to prove that C is not regular. Okay. Right. So if your first attempt at trying to find a counterexample and subsequent attempts, then just try again. Don't give up. Well, it depends. See, it might be possible that your language actually is regular, but you're so convinced that it's not regular, and you keep trying and trying and trying, and everything you try, every potential string you want to use as a counterexample,